All right, and here we'll wrap up question 3 and look at parts I, J, and K. And it's kind of more of the same, adding and subtracting rational expressions. And we'll see here, right, these expressions now are getting quite a bit messier. So for part I here, well, we'll first go ahead and build our LCD. And to do that, we're going to factor each denominator. So I have x times x minus 3 for the first denominator, and then x minus 3 times x plus 3 for the second denominator. And so for our LCD, I'm going to need an x minus a 3, and an x plus 3. Okay, so then I'm going to go ahead and rewrite each fraction so it has this common denominator. So x times x minus 3 times x plus 3, and x times x minus 3 times x plus 3. Okay, so for the first fraction, what am I missing? Well, I'm missing the factor of x plus 3. So I could go ahead and multiply this by x plus 3 to bump us up to the LCD, and then I'm going to have to do the same thing to the numerator. So that's going to give us an x plus 3 up here. And then for the second fraction, I'm missing just that factor of x. So I'm going to have to multiply this by x to get us to the LCD. So I have to multiply that 2 by x, and so that's just going to give us 2x. Okay, so then we can go ahead and combine numerators. And so I'm going to have x plus 3 minus 2x, all divided by that common denominator. And so then up in the numerator, x minus 2x is negative x plus 3, and then we're dividing that by x times x minus 3 times x plus 3. And now be careful here. Notice there's a negative x and a positive 3, and if I factor that negative out in the numerator, that's going to leave us with an x minus a 3. It's going to change the sign of each of those terms up in the numerator. And so then what we're left with is a common factor of x minus 3. And that's going to divide out. So when all is said and done here, we're going to wind up with a minus 1 in the numerator, and then an x times an x plus 3 in the denominator. Okay, so yeah, a lot more complicated, but pretty much the same idea, right? Start with the LCD and then just kind of go from there, right? One step at a time. All right, let's check out J next. So we have x squared minus 4x. I can factor out an x, leaving me with an x minus 4 in parentheses. And then for this second denominator, I can factor this as a product of two binomials. I'm going to need an x and an x. And then for the 12, well, 1 and 12, 2 and 6, or 3 and 4. And I need a middle term of negative x. So I'm going to need a minus 4 and a positive 3. Okay, so now for our LCD, I'm going to need an x, I'm going to need an x minus 4, and I'm going to need an x plus a 3. Okay, so then we go ahead and just write each fraction so it has this common denominator. And then we just got to convert each one of these fractions into these new fractions with the LCD for its denominator. And to do that, we just figure out, well, what's what's missing. So for the first fraction, I'm missing the factor of x plus 3. So I'm going to have to multiply this numerator as well by the x plus 3. So we'll get 4 times x plus 3. And then for the second fraction, we're missing the x. So I'm going to need to multiply this by x to get us to the LCD. And then that 7 gets multiplied as well. And so I get a 7x. All right, and so now I can go ahead and combine numerators. So 4 times the quantity x plus 3 minus 7x, all divided by that common denominator. All right, and then let's open parentheses and then combine like terms, and we will get there. So we'll get 4x plus 12 minus 7x, all divided by x times the quantity x minus 4 times x plus 3. And now 4x minus 7x is minus 3x plus 12, all divided by x times x minus 4 times x plus 3. And now here, kind of like what we saw in part I, there's a common factor here I can take out. I'm going to take out that negative 3 in the numerator, and that's going to leave us with an x minus a 4. And so again, we can do a bit more simplification. Since everything now is in factored form, I can go ahead and divide out this common factor of x minus 4. And so when all is said and done, we are left with the answer minus 3 divided by x times the quantity x plus 3. Okay. So again, quite a bit more involved, but a lot of the same principles that we saw in part I carry through. All right, and then on to this last one, k, x over x squared minus 6x plus 9, and plus 5 over x squared minus 3x. So here we can factor this first denominator is x minus 3 times itself, which, by the way, can be written as x minus 3 quantity squared. Okay. The second denominator, I can factor out an x, leaving us with x times the quantity x minus 3. So now to build our LCD, the distinct factors are x and x minus 3. And then as far as the exponents are concerned, well, since x minus 3 shows up as a square from this first denominator, I need a square there for the LCD. All right, and so now let's go ahead and rewrite each fraction. And these have this common denominator, x times x minus 3 squared. And so what am I missing from the first fraction? Well, I'd be missing just that factor of x. So I need to multiply this by x, and then the x up in the numerator by x. That's going to give us an x squared. And then for the second fraction, I am missing a factor of x minus 3 to get to that x minus 3 squared. So this 5 has to be multiplied by the x minus 3. And so we get that. All right. So now let's go ahead and combine numerators. So I have x squared plus 5 times the quantity x minus 3, all divided by x times the quantity x minus 3 squared. And let's go ahead and distribute this 5. So 5 comes in here and here. And so we're left with x squared plus 5x minus 15. And then we're dividing all of that by x times x minus 3 squared. Okay, whew. Now, Can we factor that numerator? Does this one simplify anymore? Well, we can try. Looking here, I would need an x and an x to build the x squared. And for the 15, my options are 1 and 15 and 3 and 5, right? So it could be 1 and 15 or 3 and 5. But if you think about this for the moment, no matter whether I choose 1 and 15 or 3 and 5, I'm never going to be able to construct this middle term of 5x. So in fact, this numerator does not factor, so we are done, which is nice because this one, you know, but at this point, kind of tired. So, but yeah, that's going to do it for this problem. Great, thank you.